All right, let's talk about implicit differentiation. Sometimes we're going to be taking the derivative of something that's not a function. So most equations that we deal with are in explicit form, meaning that they are expressed as functions. However, equations can also be expressed in implicit form because some equations cannot be expressed as functions. I've already written some stuff. I'm hiding it from you. But let me show you just a little bit here. This is a function. Y equals blah, blah, blah. This doesn't look like a function, but it can be very easily. If we subtracted 4x, we'd have y equals 3 minus 4x. That's a function. That's not a function. You can look at the graph and tell it's not a function. But we can take the derivative of any of it. And so we're going to be doing that using implicit differentiation. But the first thing we need to do is remember what dy over dx means. And it is the derivative of y with respect to x. You're going to hear that phrase a lot. And also, you see a little white out on my paper. I goofed up just a little bit. Also known as y prime, okay? This is the Newton notation. This is the Leibniz notation, but we are taking the derivative of y with respect to x. Things are going to get a little bit tricky in the way things go here. And it's kind of difficult to explain, but it's going to involve the chain rule. Let me go ahead and give it a shot now. If I am taking the derivative of y with respect to x, then I'm just going to take the derivative like I've been doing, like this. Let me show you. What's the derivative of 6x to the fourth? Oh, 24x to the third, and we're all happy. Hey, what's the derivative of 6y to the fourth? Oh, 24y to the third, and we're not all happy. And here's why. When I took the derivative of this, there was a y involved. I am dealing with a composite function. Y is something. And because of the chain rule, I have to multiply by the derivative of this inner part. Okay? Up until this point, we've had composite functions that looked like composite functions. But now we have 6 times y to the fourth. Y is some expression because I am taking the derivative of y, not x. I'm taking the derivative of y with respect to x. So y has the potential to be some expression involving x. Because of the chain rule, I keep pointing at this y like he's up to something. Because of the chain rule, I must multiply by the derivative of this inner function. The inner function is y, so we will multiply by the derivative of that. Okay, if nothing I just said made sense, let's try this one more time. If I said, let's take the derivative of this, then I can do a chain rule on this thing. And I would say the biggest thing happening is 6 times something to the fourth power, which would give me 24 times something to the third. Well, what is that inner thing? It's y. Well, what's the derivative of y? It's the derivative of y. This goes here, and I would have 24y cubed times y prime, y prime, times y prime. This y prime is represented in this context as dy over dx. Also y prime, same thing. Okay, let's keep moving. The derivative of 2x is 2. The derivative of 3y is 3, but I just took the derivative of a y with respect to x. Here's an alternative explanation for that big rambling that just happened. If I took the derivative of y with respect to x, because this is an x and this is a y and the variables disagree, there is some inner function that must be accounted for, and we multiply by the derivative of that inner function. Okay? Let's go again. This is going to be a product rule. There's that, there's that. This is F, this is G, and this is going to be a product. We're going to have F prime G plus F G prime. Anytime I take the derivative of something that does not have that variable in it, sometimes later this will be a t, and you're going to have to put dy dt or dA dt or whatever. If this variable disagrees with whatever variable you're taking the derivative of, you need this extra factor. Okay, again, back here. Taking the derivative of 2x with respect to x, don't need it. Taking the derivative of 3y with respect to x, that's a y, that's an x. I need this for chain rule reasons. All right, we'll get the hang of it. Here goes. Let's move on. I've had to explain this a lot several times in the past, and it's a wacky concept. F prime g plus, okay, pause for a second. I did not take the derivative of g. I'm about to, though. Plus f. I just messed up, and it's not too tragic. F prime would be just 2, not 2x. Sorry, just 2. Sorry about that. 2y, these are multiplied. There's just a big gap. Plus f g prime. The derivative of y is 1. But I'm taking the derivative of y with respect to x. Therefore, I need this. Okay, just to space everything closer together, this is 2y plus 2x dy over dx. Okay, let's expand this idea in the next video.